Welcome to the session on the topic orbital quantum number. In this session, we are using Concepts of Modern Physics by Arthur Beiser as the reference textbook. The orbital quantum number is represented using the small letter L. It must be less than the principal quantum number n, which corresponds to a shell of electrons. Thus, this L divides each shell into n subshells consisting of all electrons of the same principal and orbital quantum numbers. Taking the differential equation for the radial part r of the wave function psi, we get the equation 1 by r square d by dr into r square by dr plus 2m by h cross square into e square by 4 pi epsilon 0 r plus e minus L into L plus 1 divided by r square the whole into r equal to 0. This equation only concerns the radial aspect of electron's motion, that is, its motion towards or away from the nucleus. So in this equation we can see a term E, that is the total electron energy, which includes the electron's kinetic energy of orbital motion and which has nothing to do with its radial motion. This is a contradiction. The above contradiction may be removed by the following argument. The kinetic energy Ke of electron has two parts, Ke radial due to its motion towards or away from the nucleus and Ke orbital due to its motion around the nucleus. The potential energy U of the electron is the electric energy, that is, we all know that U equal to minus E square by 4 pi epsilon 0 r, which can be also written as U equal to 1 by 4 pi epsilon 0 into minus E square by r. Therefore, the total energy E equal to K radial plus K orbital plus U, that is equal to K radial plus K orbital minus E square by 4 pi epsilon 0 r. Substituting the value of E from this equation to the above equation and making a slight rearrangement, we get the equation as 1 by r square d by dr into r square dr by dr plus 2m by h cross square into k radial plus k orbital minus h cross square into l plus 1 by 2m r square the whole into r equal to 0. If the last two terms in the square brackets of this equation cancel out each other, then this will be a differential equation for r of r that involves function of the radius vector r only. Therefore, we need to assume that k orbital is equal to h cross square L into L plus 1 by 2m r square. We all know that the equation for kinetic energy is given by half mv square and angular momentum as L equal to mvr. Here we are only considering the orbital part of kinetic energy, that is Ke orbital equal to half m v orbital square and angular momentum L equal to mv orbital r. So we can substitute and rearrange and we can get that K orbital is equal to L square by 2m r square. Also in the above equation we have K orbital is equal to h cross square L into L plus 1 by 2m r square, and substituting the value of K orbital is equal to L square by 2m r square, we get the equation L square by 2m r square is equal to h cross square L into L plus 1 by 2m r square. Cancelling 2m r square from both sides, we get L square is equal to h cross square L into L plus 1. That is L equal to root of L into L plus 1 into h cross. That is the electron angular momentum. The orbital quantum number L restricted to the values L equal to 0, 1, 2, 3, etc. up to n minus 1, where n is the principal quantum number. The electron can have only the angular momenta L equal to h cross into root of L into L plus 1, and the angular momentum is both conserved and quantized. Designation of angular momentum states we use certain letters to specify electron angular momentum states. They are S, P, D, F, G, H, I and etc. S corresponds to L equal to 0, P corresponds to L equal to 1, D corresponds to L equal to 2, F corresponds to L equal to 3 and etc. So for n equal to 1 we have L equal to 0 and 1s is the atomic electron state, and for n equal to 2 we have two atomic states, that is 2s and 2p for L equal to 0 and L equal to 1. Then for n equal to 3 we have three atomic electron states and they are 3s, 3p and 3d for L equal to 0, L equal to 1 and L equal to 2. So this is a table which provides us the idea of atomic electron states. This peculiar code originated in the empirical classification of spectra into series called sharp, principal, diffuse and fundamental, which occurred before the theory of atom was developed. Thus an S state is one with no angular momentum and a P state has the angular momentum √2 h cross and so forth. So the combination of the total quantum number with the letter that represents orbital angular momentum provides a convenient and widely used notation for atomic electron states. In this notation, a state in which n equal to 2 and L equal to 0 represents a 2s state. That is all about my topic. Thank you.